name is Marco. I work at ASOS.com as a software architect on the iOS and Android teams. And I'm here with Ed, who is one of our senior Android engineers. For those of you who are not familiar with it, ASOS is an online-only fashion retailer, quite big in UK, but also we operate worldwide. We've got 26 million active users and more than 3 billion visits only in 2021. So it should be quite interesting for you to see what we are doing, hopefully. Our talk is about how we do A/B testing in our iOS and Android apps with a configuration-driven approach that allows us to release tests without having to deploy a new version of the app every time. Most of what we are going to show is almost completely platform agnostic, which means that after the talk, if you like the approach, you can go back to the office, or more likely back to home, and implement it for both Android and as well as for iOS, or maybe tell your iOS colleagues to implement that on iOS. I suppose most of you are familiar with what A/B testing is, but just to do a quick recap. A/B testing means splitting your audience into two or more groups and give each group a slightly different version of something. So show them a slightly different UI or have a different UX and be able to measure which variant performs the best in terms of either sales or revenues or engagement, length of sessions, frequency of the sessions, etc. And of course, you might want to determine the success of a variant according to different metrics, according to your type of business or type of the app. So of course, if you're an e-commerce app, you're going to look forward to better sales and revenues. If you've got a game, maybe it's length or frequency of the sessions. And of course, once you have confidence about which one of the variant is better for the users, then you're going to enable that as the winning variant so that everybody gets it. And testing basically helps you validate ideas with data so that can make data-driven decisions rather than applying personal bias. So, of course, we all like to think we have good ideas, but really few people are infallible. So this is just puts science into the picture and allows us to make safer decisions. So there are three different approaches that we used in our apps over the years for testing, and we're going to go through these three to give you an idea. So the first approach is fully client-side experiments, which is when you want to change something on the client side, like you want to change the UI or the layout of something. So for example, you might want to change the color or some other styling or the position of something, or if you want to, or you might want to change the UX of something. So for example, splitting a long form into multiple steps. And the way you do this is that everything really is done on the client side. So you do the bucketing, which is the action of splitting the users into different groups and assigning them to a variant. And you implement a change for different variants. You do the tracking of events that you need to measure the success. And everything else, you do everything on the client. The pros of this approach is that because everything runs on the client, you know everything about the users. So you know who the users are, if they are from a given country or another, etc., etc. And so you can create very specific audiences. So for example, you might want to run a test, not for everybody, but just for users that are logged in, that are from a given country, that made, I don't know, a number of orders with the app already in the past, and so on. So you can be very specific. Also, because everything's done on the client, you've got complete freedom in what you can change. So you can change really anything that you want in the app, in every part of the app. And you can also track events anywhere in the journey because you control the journey end-to-end. And also you don't have external dependencies, so it's all your work, so you don't have to wait for any other external team to do work for you. So you can have your own schedule about the releases. There are also a number of downsides, however. First of all, every time you want to implement a test, you need to do work on the client side, which means that you need to do the work, package the work into a new build, release it to the users, wait for the users to be on board with it, so to download it, etc. So the process is quite slow, and it doesn't really scale well with if you want to release many tests. And also, if you want to apply the test on multiple platforms, so iOS plus Android plus maybe web, it means that every platform have to duplicate the work. So it's not really ideal in that sense. A couple of examples of this approach is so on this screen, for example, you see our product page, and on the right-hand side there is a V2 of the screen where just below the price of the product there is an additional line that tells the user that they can pay in installments, so they can split the payment into three parts with thanks to Klarna, which is one of the payment methods that we integrate. And I promise you, it's more visible if you have the device a few inches from your face. And this is with the idea, of course, that if we tell that the user about that before they enter checkout, in theory, they should be more enticed to add to bag because they know that they don't have to pay everything at once. So that was the idea that we wanted to validate. As a second example, we might want to change the copy of the green button from add to bag to buy now. And if the second version, buy now, works better, maybe there could be a follow-up experiment where if you buy the buy now button, you might go to bag in one case, to the bag screen, or you might want to skip bag completely and go straight into checkout. Maybe because you have got the idea that if you streamline the experience and remove one step in the journey, maybe it works better for the user because the journey is quicker. Okay, so this was the first approach. The second approach is fully server-side experimentation. And this is when you want to hide the details of how something is activated, so you want to keep it secret on the server side. And this for when for things like you are experimenting with the pricing, for example. You want for that to stay isolated on the backend. Or maybe for when you want to do engineering experiments. So for example, you might want to see if by changing the schema of a database table, or if you introduce caching, or if you change the technology for something that you use on the backend, you want to see if that brings better performances, or if it increases the number of concurrent requests that the backend can handle. The way it works is similarly to the full client-side experiment, is everything is done on one platform, but in this case it is the server side. The pros are that for the backend it is a little bit easier to deploy their change because they deploy once and it's available for everybody. So they don't really have to wait for people to get a new version, etc., because that's just the difference between releasing an app through the app stores, etc., and releasing something on a server. And also the other benefit is that like there wasn't dependencies to other platforms on the client-side experiments, also backend, if they do the experiment on their side, they don't have dependencies on other platforms. They release once, and all the platforms get the new version, and also when they decide which is the winning variant, all the different users on all the different client platforms benefit from the variant that they applied. The downsides, however, there are a few also in this case. And first of all, the backend might have much less knowledge about who the users are, especially if the API calls are unauthenticated. So it might be difficult or impossible potentially for the backend to create a very specific audience. So they can't, for example, run an experiment only for people in given countries or only for certain type of customers unless they know about the users, because there are parameters that tell the backend about that. But that's not always the case. Also, it's more difficult for users, for the client app and for the QAs to test a specific variant if if they need to do that, unless maybe there is a secret param that is only used by QAs to force a specific experience. But that means additional coding for both the client side then and also for the backend to support it. So it's not really usually the case that is implemented. Another downside is that if you have multiple services on the backend, all separated because maybe you have got a microservice-based architecture and you want to apply experiments on many of these services, it means that all these services must do work, must duplicate work to integrate with a third party, which is maybe the third party that does the bucketing and that assigns the variation to the call, to the request. It means that all of them have to integrate with a third party or the SDK that does that. So again, it's duplication of work, just like it was the case for the client-side experiments, if you wanted to do the experiment on multiple platforms. And finally, it's very tricky or potentially impossible to do proper tracking of metrics, especially if you want to track the benefit of something somewhere else in the journey. So you do something on the backend on one screen that the user is on, but then maybe the benefit of that is visible much further down the line in the user journey. So with fully server-side experiments, you can't really do that, or maybe it's tricky. The third approach is what we call hybrid approach, and it's when you've got UI that is dynamic and it changes according to what the API gives back to the client, basically. And the way it works is that you do the bucketing of users on the client side, and then the user is assigned a variant. According to that variant, when some API call is made, a parameter is appended at the end of the API call, telling the API what version of the response it should return. And according to the response, the client side is going to build the UI dynamically. And we're going to show you a few examples in a minute to make it clearer. The benefits are very similar to the benefits of the first approach, with additional benefit that for the client side at least, this approach is easier, is faster, because all the logic to change the content is done on the backend, and on the client side, it just dynamically builds the UI according to the response, but it doesn't have to have the logic to change the response. All that is done on the server side, and the client just reacts to that. The downsides, however, are also very similar. So you still need to release a new version of the app every time there is a new test implemented. But in addition to that, in this case, there is also a dependency to the backend, because it's a combination of things, right? So there is a change on the client side to send the new parameter and to do the bucketing, and there are also changes on the backend to be able to support the new parameter and then return a different response. So, of course, you have to synchronize the changes on the client side and on the backend. A few examples of this approach. So we've got a homepage API that provides the content of the homepage screen. And so it returns JSON representing blocks of content, and every block has attributes that specify what is the background image of the block, for example, what is the text, and there are a number of attributes that determine the styling and the position of the blocks and so on. So on the example on screen, you see that on the right-hand side, we call the API with an additional tst-var parameter, and when that is set with that value, the sale block is moved up, is moved at the top of the page, and it has a different styling. And this was maybe to test if by putting something at the top of the page with a yellow background for the text, maybe that's going to work better. So it's going to receive more clicks, and we are going to sell more. Similarly, we also have a category listing page where we show the tree of categories to navigate the catalog. And you see here that on the right-hand side, the item of the navigation pointing to beauty products, pointing to a sale for beauty products, is rendered completely differently. So it is much more visual, it's bolder, it's bigger, it has a different image, a bigger image with a background color, etc., etc. And this also is all dynamic, so we don't have to make changes on the client side because the client side is, has logic from the very beginning to be able to render different items of the tree with, according to all the styling attributes that the API returns. So only the API changed in this case to return JSON, which was different in the second case to apply. To have different attributes that that describe how the first item in the page must be rendered, and on the client side we just respect that JSON. Of course, you must design the client side from the very beginning to be able to be dynamic in terms of rendering according to a number of attributes that the API gives you back. Third example is the search page, which the product listing page displays products returned by search, and search, according to the parameter that it gets, can use AI and maybe different models of AI to recommend different products at the top of the search results. And finally, I've got an example for the product page, which is powered by product API, which returns plenty of metadata about the product, plus a list of image URLs. And on the right-hand side, you see that with additional parameter, it returns 8 images rather than 4, and also it changes the first image that you see immediately as you open the product page. So this approach is interesting because we've got to do little work on the client, and most of the work to change the content that the users are going to see is on the back end. However, there are still work to do on the client for every experiment, which is the bucketing logic again, and it's changing the URL to an API request just before the API request is made, and you still have to package the change into a new build, release it, and wait for the users to get it, right? So this didn't really work great for us after some time because it doesn't really allow us to make the company happy, because the company, the business wants us to make an ever-increasing number of tests, and this approach that just doesn't scale as well as we would like. So enough about the problems. Now Ed is going to show you the hopefully more interesting part of the talk, which is about the solutions that we've put in place.
Lovely. Good morning, everyone. Thank you. Thank you for joining me and Marco. Marco has kindly let me do the fun bit of the talk where I get to say how we've solved this problem at ASOS. So at ASOS, we've actually solved this problem in kind of 3 key parts. The first part, and the first kind of idea that we came up with, was having a manifest file of all of our active experiments. So these are all of the experiments that are running in our app at any given time. And this is downloaded kind of as the app starts up and gives us an overview of where the experiments are being run. And this is done by cataloging which URLs these experiments apply to. And yeah, it's done in a way where the experiments can be kind of retrieved once we query the API. So the next kind of step is something that we are returning from our A/B testing partner, which we will get into shortly, which is a list of each, for every experiment returns a variation. And within that variation, we get metadata, which explains how we should modify our API requests to serve the user a different experience or a different a different experiment, as Marco just showed in a couple of the images previously. So we can kind of modify the API in a number of ways. We can add or remove or append query parameters. We can change headers. We can change the request in pretty much any way we like. We kind of have stuck to query parameters and headers, but there's no reason why, depending on your own API, you can do other things as well. And finally, the kind of key part of this, to tie this all together, is we have in code, we have, in our network layer, we have code to modify our network layers for all outbound requests to add these experiments where required. So these could be your regular API calls, these could be your image requests, they could be whatever you want. We change the request dynamically as the user navigates through the app and makes these requests. So let's take a quick look at what a manifest file, the first step of this, might look like. And it's pretty standard JSON. I think everyone here should be okay reading this. So we have a list of tests. And for each test, we have kind of the feature key, which is the name of the experiment. And we have a list of rules that that this experiment would apply to. So in this example here, and it's actually an example Marco showed before, we would be looking at the navigation tree API, and we have a specific pattern that we're looking for. So when the user makes a call to the nav API, and the endpoint has got a country of set to either GB or IE, this experiment would apply. So we would call our A/B testing partner for this experiment, get the metadata back, and change the URL. But we'll go into that shortly. So let's have a look at let's say we've called this API, and we've queried for our experiment, we've been bucketed, and we get our variant back. What information do we need in the metadata? So the metadata here, again, you can have one or more of these kind of per experiment. In this case, we are changing a query string. We have got one rule here which says basically replace the test var query parameter string with a value, and this value here would be beauty v2. So some users would get beauty v2, some users may get beauty v1. You could have beauty v800 if you wanted. And at runtime, when we query the API, we would make this change based on which bucket you've been placed in. So yeah, I guess in terms of how our app works, I'm hoping this will be kind of a familiar picture to most of you of how our app is kind of structured architecturally. For our homepage, for example, we have UI that talks to view models that talk to our repositories, and the repositories talk to a number of data sources, be it local or remote. And in this case, we kind of have a wrapper around our network that is shared across all of our apps. So whether it's the homepage or navigation tree, search, product details, I'm hoping this is kind of a familiar picture to most of you of how your app is structured. So once we have this kind of common network wrapper, that gives us the ability to implement the kind of third stage of the three-part solution, which is the network interceptor. So kind of give a brief sort of flowchart of how, I hope you can see this by the way, a brief flowchart of how this kind of works. We take the incoming network request, we check it against our pre-downloaded manifest of experiments to see if the URL matches. If it doesn't match, then we let the network request go on its way and it's served to the user as normal. However, if we find a matching experiment for that given URL, we get the variation from the experiment from our A/B testing partner, and based on the rules that came back, we modify the request in any given way. Again, query string parameters, headers, however, you could do the body of the JSON if you want, and then we fire the API request to the network. So let's go through an end-to-end flow. So just to hit home exactly how this works and how straightforward this is. I mean, I think this is something you could probably implement in the majority of your apps fairly easily. So let's say we are making a request like we just looked at to the content nav API. And in this case, we've got the query string appended. This time it's the country's GB. The first thing we would do, again, is query our manifest file. At this point, the manifest file should probably be already stored locally, so you will have got this probably at runtime, at startup. And we go through and we check to see if there's a matching test. And in this case, there is. We've got the matching test for the beauty banner. So the next step is querying our A/B testing partner. At ASOS, we use who do we use? Optimizely, thank you. I've completely blanked out. Optimizely, we also use, you could use Firebase, you could use Taplytics, you could use whoever you want here. It's completely agnostic. You can use a solution with any A/B testing partner that you want. So In this case, we've got the metadata from our experiment, and it tells us to modify the query string parameter. So what we do is we do just that. We add the query string parameter based on our rules, and what the user sees is the variation. So depending on where they've been bucketed, they will see the variation. So yeah, that's pretty much the end-to-end flow there. But how would we do this in code? Well, in code, this is relatively straightforward. I imagine the majority of you here will be using something that uses OKHTTP, be it retrofit, or OKHTTP itself, or Apollo GraphQL. There's kind of a lot of different solutions now that use OKHTTP. And what OKHTTP allows us to do is add interceptors. What we do at ASOS is we use a network interceptor. And a network interceptor is different. There's kind of two concepts within OKHTTP. You have interceptors and network interceptors. And network interceptors kind of are the last step of the process before it's fired to the network. So an interceptor, so you would take your request, it would go through OKHTTP, and then just before it's fired to the network, you would use OKHTTP's network interceptor to intercept the request and make the modifications. The difference being between an interceptor is that it would do it prior to OKHTTP receiving a call. So the code is very straightforward. We define our URL injection experiments interceptor. We add it to the chain of our OKHTTP builder. This should be your global OKHTTP instance, which you can inject yourself using any common injection framework. And yeah, we can build it. So within the interceptor, we have, it's a interface that OKHTTP provides. So we have the concept of the intercept, and the intercept takes a chain, and this is kind of a chain of command pattern. So ideally, we want to use this interceptor as kind of the last step of our chain to make sure that any other modifications by any other interceptors are done prior to this. And yeah, we kind of, again, have three key parts within this interceptor. This is all kind of pseudocode, and please make sure you catch us after for the slides. There is kind of a bigger, more sort of well-formed code block at this, but I think because of time, we'll kind of skip that today. But the first step is to make sure that we get all of our experiments, which we will get from our manifest. So that's simply the loading of the manifest. The next step is to find all of the matching experiments. Now, this is done primarily by, first of all, checking the base URL to make sure that it matches. And then, as a secondary level, pattern matching against the endpoint if there is any regular expression rules that need to be applied. And finally, we can build a new request. So this is the step, once we've got all of the changes that need to be made to the experiment based on where we've been bucketed, we will make the changes to the headers, to the URL, to the body, etc. So how do we modify an HTTP request? Well, thankfully, OKHTTP is a brilliant library, and it's really straightforward to do. So yeah, sorry for the wall of code, but in this case, we will take existing query parameters, and depending on the operation that we've been assigned from our rules, we can append to the query parameters, we can remove them outright, or we could replace any pre-existing ones. And again, please do check the slides afterwards for a full kind of example of how to do this. But this is kind of, again, this kind of pseudocode is very agnostic. This could equally apply to headers or, again, to the body. So the good news is this kind of solution has worked really, really well for ASOS. And I'm really pleased to be able to say that this has been in our production app for just over 3 months. Currently, we're using about 10 experiments, but that number, again, is increasing all the time. Now that it doesn't require a release to modify these experiments, the teams can add experiments pretty much at will. The main big win here for us was that the time to go live with experiments was reduced from 2 weeks, which was kind of our release cadence. And now it takes 1 to 2 days. So if a team wants to implement an experiment, they no longer have to wait for us to release the app. It's not like waiting for a bus anymore. The bus is there right away. They can go and release their experiment straight away, which is brilliant. However, it wouldn't be a talk unless we did talk about a couple of the challenges. The manifest file itself at the moment is kind of manually generated, and this is the manifest file of all of our experiments. In an ideal solution, this would be kind of generated or validated to make sure that any changes to this manifest file, don't break the app, because if we break that manifest file, none of your experiments are going to run, and you're going to have a lot of angry emails. The next kind of, the only way that you can definitely get around a release is making sure that you have got the ability to measure success for your experiment in the app prior. So what I mean by that is you need to make sure you have the analytics in place for any given experiment to be able to say this experiment was a success. So in the case of new experiments where we might be measuring a new metric that we don't have in the app, so for example, if you have an app that doesn't yet have the ability to make purchases and you add a new flow to add purchases, you'll need to make sure that you've got analytics in place to be able to say any experiments within that flow would be a success. And finally, if you're not a regular expression wizard and you've got complex URLs, then this might not be the solution for you, or you may need to get a degree in regular expressions. But then again, regular expressions is difficult for everyone, right? So this is probably the only other downside I can think of. And that's it. Thank you for being bucketed in the talk where I kind of did an all right job. If there's any questions, we'd love to have them. Thank you. Also, yes, quickly, we are also hiring. Please do come find us downstairs. We're at the booth. We'll be there the majority of the day, so please do come find us. Yes, questions? Yes?
So, assuming a test goes well,
yep.
You're happy with the results, how do you offboard a test into just being not a test, but a real feature?
Do you want to take that one, Marco, or shall I? So the question was, if a test is a success, how do you stop it, basically? How do you make it become a feature? Well, the truth is you do have to do an app release. So it would be refactoring the code to make sure that you get whatever you want, whatever the successful sort of scenario was, becomes the norm for everyone. So you would outright remove A/B testing from the app in that particular scenario. So the alternative is that through A/B testing partners, you can, and there is ways of bucketing users, so 100% of users get an experience every time, although that might not be what you want.
So you typically first enable the winning environment for everybody for a given time until you hard code the new URL into the next build of the app, so that you, like, over time you clean up in the manifest files the experiments that are finished, and you just use the final URL.
Thank you. Yes, down front.
Thank you. Yeah. So, what is the strategy to re-download manifest file? How often do you refresh it?
We do it at every app launch. It's not every app launch. Yeah. So it's not. I wouldn't say it's critical to have it more than that. But we do download it every app launch in case there's new active experiments, in case experiments have been removed. Yeah. So that's why we do it at launch.
I mean, that really depends on your specific business case. So you might want to refresh it every app launch, or whenever the application is brought back to foreground. In our case, for example, we download it every time, but also cache it for later, so that if the next time you launch the application, it fails downloading for whatever reason, then you've got a cached version already in place, so that even in that case, you can apply the previously defined experiments. Also because, I mean, they are added frequently, but probably if you use a previously cached version of the file, is probably good enough.
Sure. There's one more question. Yes.
Hello, thank you for the talk. Currently in your solution, the manifest file is, let's say, the weak point. You mentioned if someone changed something that it should not change, it may break things. How are you currently ensuring that even if something changed, is not going to affect? I mean, this is just like a JSON file that you have somewhere in some server, or are you applying some kind of unit testing or trying to automate or safety measures in order to avoid those unwanted changes?
So we wanted to keep the description of the approach quite generic, so that it would be applicable for most of the apps or in your cases. In our specific case, we don't really have a separate manifest file. The content of the manifest really comes as part of the Optimizely file. So Optimizely is the third-party tool that we do for A/B testing, and the way it works is that it has its own data file with all the different all the JS for the different variations for all the experiments, and we use one special kind of experiment, just that we don't use an experiment per se, but we just use to put all the manifest data in it. So in our case, if Optimizely works, we get everything at once, manifest plus everything else. If it didn't work, we wouldn't have even the experiments data. So, I mean, it wouldn't be a problem for the manifest, it would be a general problem. But as mentioned, we still cache it for later. So if it doesn't work on that session, we might have downloaded it before on a previous session. So yeah, it's very reliable. But yeah, you might want to, if you go with a manifest file, you probably want to keep it on a CDN so that it is very reliable and also very, very fast in downloading, rather than maybe putting it in a regular API, which is maybe slower, or like that. CDN is probably your safest bet.
Thank you.
Thanks, everyone.